here we're going to look at finding the inverse of a function, and we're going to try to tell them the domain and range of that inverse. So first thing, let's try to find the inverse. So if I have this function, it'll be easier to do if I think of this as y. The first thing I want to do is switch x and y. So here, where there used to be a y, or my output, I'll put x. And then everywhere there used to be an x, I'll put a y. And then I want to try to solve for y. So first thing, I'd like this out of the denominator. So I multiply both sides by 3y minus 7. And that means I have to distribute x here. So this will say 3xy minus 7x equals y. Then I'd like all the stuff with y on the same side as each other. So it's up to you what order you want to do it in. I'll probably subtract 3xy over to this side. And so notice I have y in two places. How can I get it by itself? Well, it's a common factor between these two terms. So if I factor out y, I'm left with 1 minus 3x. And so now if I divide by 1 minus 3x, I get this divided by. So there's a possible inverse. If you don't like all the negatives, if you factor a -1 out of this, and doesn't make a difference, it should take this answer either way. But if you factor a negative out of this, notice that makes it a -1 and plus 3x is the same as 1 minus 3x. Then this and this negative could cancel. So you could write your inverse like 3x minus 1. Totally up to you if you like that or think it looks better. All right, so let's write down our inverse function underneath our function here. All right, then think about what does our inverse do. The inverse goes the opposite, takes all the things from the range of the original function back to the domain. So if they want the domain of f inverse, the domain of this function we just came up with, what's the only number we can't put in there? Looks like anything except for what would make the denominator 0, what would make the denominator 0. So add 1, divide by 3, so it looks like 1/3 is the only number I can't use. So the domain is anything except for 1/3. So negative infinity up to 1/3, skip over 1/3. So anything but 1/3. All right, how do I find the range? Well, picture if we're going back to here, the range of f inverse is the same as the domain of our original f. So we can look at our original f equation and say, well, what was the only thing we couldn't put in there? So for this denominator to equal 0, x would have to be 7/3. Add 7, divide by 3. So over here, I can do anything, or I can reach any numbers except for 7/3 because they weren't in the domain of the original function. So when I reverse it, this is the domain of f inverse, this is the range of f inverse.